A client met his banker to discuss opening a restaurant in a busy airport. In us, he found a partner that understood the importance of reaching for the sky. First Horizon Bank. Let's find a way. Go to firsthorizon.com/Mac.
Today's show is brought to you by ExpressVPN. Protect your online activity today and find out how you can get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Visit tryexpressvpn.com/space to learn more.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2.
1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello once again. Thank you for joining us on this podcast we like to call Space Nuts, although we're not sure there are any nuts in space, but there are plenty on Earth. I'm one of them, and Fred is not. Fred Watson I'm talking about from the Australian Astronomical Observatory. Hello, Fred.
Why can you be a nut, but I can't be?
I was trying to be polite, but if you want to be a nut, that's fine. That's fine with me.
I mean, as the blurb says, may contain
traces of Fred Watson and Andrew Dunkley. Yeah, good point.
Watson.
That's on our logo. Yeah, I should have remembered that. Oh, well. Now, today, Fred, black hole clusters may exist in their thousands, it sounds like. This is an unusual prediction and maybe a discovery. Virgin Galactic has just done a test flight of VSS Unity, and that's the first time they've been up there for, nearly 4 years after a tragic accident in 2014. And a question from our studio audience: what do we actually see from Earth? Is everything we see in our galaxy, or is there other stuff out there? And it's a good question because I think most of what we see is in our galaxy, but a lot more is not. That doesn't make sense. Anyway, we'll get to that. But first, Fred, let's talk about this situation with black holes. We've talked about black holes before and how they only ever came in 2 sizes, and this story does allude to that. But now they're starting to think there's a little bit more going on here.
Exactly so, and you're quite right. They do seem to come in 2 sizes, the very big ones and quite small ones. So just to recap, we now think that most galaxies, like our Milky Way, hundreds of billions of stars and gas and dust and all the rest of it, we think that most of them at their centre have a black hole. And these are big black holes, and they're presumably big because they've grown over the lifetime of the galaxy, although once again the jury's still out on the origins of all that. But for example, we know that there is a black hole at the centre of our own galaxy with a mass of 3.6 million times the mass of the Sun. So it's a big one. It's what's called a supermassive black hole. Actually, some of them are billions of times the mass of the Sun. So it's a fairly modest supermassive black hole. But the other category is ones that come in maybe 20 or 30 times the mass of the Sun. So these are what are called stellar mass black holes because they're the mass of a star, roughly, or a big star anyway, and the other ones are the supermassive ones. And there doesn't seem to be really anything in between. There have been a few discoveries made of things with maybe 200 times the mass of the Sun, but they don't seem to be there in great numbers. The small ones are and the big ones are, but the ones in between are not terribly, they're not populous.
They're not common.
So they're not common, that's the word, yes, or not commonplace, how's that?
Better.
Yeah. Yeah. The story that we're talking about today, though, is about the fact that there is a prediction that if you've got a big supermassive black hole at the center of a galaxy, it should be accompanied by swarms of much smaller ones. In other words, the stellar mass black hole should kind of cluster around the big supermassive one. There are a number of mechanisms that are suggested for this. The theory seems clear that there will be these things, but exactly how they're formed, there are a couple of possible different ways. We don't really need to go into that for this story, because this story is about the fact that we've now confirmed that is the case.
So it is actually confirmed.
Yes, that's right. So there's a nice detective story here. These are scientists from Columbia University in the USA. And what they've actually done is they've looked for what are called black hole binaries. And this is where you've got a black hole and something else, which is usually a star. They're in orbit around one another. A binary is when two objects are orbiting around one another. So you can have binary planets and binary stars. Actually, binary asteroids, there are quite a lot of those as well out there in our own solar system. So they've looked for that because if you've got a black hole with another star near to it, what tends to happen is that the black hole sucks material off its companion star, and that forms what's called an accretion disk, a disk of swirling material around the black hole. And occasionally you get a big chunk going into the accretion disk and it flares up in the X-rays, in the X-ray region of the spectrum. We don't see these things in visible light. We see them actually by what you might call invisible astronomy, and that's things like X-ray telescopes. So the scientists at Columbia University, what they've been doing is looking for an X-ray flash when some chunk of material gets sucked off a companion star and into one of these predicted black holes. But they haven't seen anything, and that's because such events are probably relatively rare. Even though the belief is that our supermassive black hole may be accompanied by up to 10,000 smaller black holes. It's not a small number of objects around it.
That's a staggering number, really.
It is, that's right. It's a very large number. And so you might say, well, at least one of those things should flash off occasionally and we should be watching for it. And they've been watching, but they haven't seen anything. So they changed their strategy, which is what you tend to do when you're going down a blind alley. And instead, they looked for the sort of steady signal that would come from the accretion disk itself. So you've got this disk of material that's swirling around the black hole. All the stuff is intermixed. Everything's crashing into each other in that disk, and that itself releases X-rays. So you don't have to wait for a big chunk of star to fall into your black hole and look for the X-ray signal from that. You've got a kind of background of X-rays, and the critical thing is that they are different. The X-rays that you get have a different energy from the X-rays that you would get if you found some big chunk falling into the accretion disk. Now, when we talk about energies in X-rays, Andrew, it's akin to talking about color in light. So high energy X-rays are like blue or violet light, which is high energy light. Low energy light is red. It's at the red end of the spectrum. We usually think of it in terms of wavelength when it comes to light beams, but in the X-ray scientists always talk about energies. That's because they use similar techniques to the particle physicists who measure solid lumps of things, which you talk about their energies. There is a curious thing there, because in quantum theory you can talk about the wavelength of a solid chunk as well, but we won't go there. That's just too complicated.
That'll give me a headache.
Yeah, it gives me one too. All right, so what they've done is they've said, well, let's look for X-rays at a lower energy than the ones we were looking for before. In other words, the sort of analog of red light rather than blue light.
Yeah.
And in the hope that they will see this constant source of X-rays coming from the accretion disk, the disk of material swirling around the black hole. And sure enough, that's paid off, because they've teased out this signal from the galactic center of objects very close to the supermassive black hole at the middle of our galaxy. In fact, within, I think it's something like 3 light years of the of the supermassive black hole, which, remember, is 25,000 light years away from us here on Earth. It's a long way off. So they found a dozen of these signals from X-ray signals from the disk of material around the black holes, and have written this up in a paper which suggests that what we're seeing is the kind of tip of the iceberg of these huge numbers of black holes that are thought to be swirling around the black hole at the middle of the galaxy, around the supermassive black hole. So it seems like a very successful story. And what is probably going to happen is people will continue looking, and we'll find more and more of these things, because that's the way it works in astronomy. They may even find hundreds of them that that will tell us more about the environment within the inner 3 or 4 light years of our own galaxy.
And brings up questions about the relationship between supermassive black holes and small black holes, and why would there be, upwards of 10,000 of them all clustered together like that? It's a whole new area that needs to be investigated by the sound of it.
That's right. The two theories for why you should get these things around a supermassive black hole is, one is fairly intuitive. It's the fact that there is a strong gravitational pull from the big black hole. And so the smaller black holes, which are themselves, they've got plenty of gravity because these are probably 20 or 30 times the mass of the sun. They get pulled down, in much the same way as things sink to the bottom of a pile of, let's think of the fluid. If you put heavier liquid inside a lighter liquid, then the heavier liquid will sink to the bottom because the gravity of the Earth pulls it that way. So it's that kind of thing. It's these things just trapped in the vicinity of the black hole at the center of the galaxy. And there is an alternative possibility, and that is that we know that the center of our galaxy is rich in very massive stars. Because that's where all the gas and dust is that surrounds the supermassive black hole. So there are massive stars which form from that stuff, and then they themselves, at the end of their lives, would form stellar mass black holes. So you've got two possible theories. One is that the raw material for black holes is already there around the center of our galaxy, so that's why you get lots of them. And the other is that the ones that are lurking around a bit further out get pulled in anyway by the gravitation. So either way, you're going to find more of these stellar mass black holes in the vicinity of the supermassive one. And that seems to have been borne out by the observations.
And again, the possibility of this being a common thing amongst other galaxies, I suppose, will be a matter of time when we see it elsewhere.
That's correct. Yeah, it's the difficulty is actually in other galaxies, because the distances, the nearest big galaxy to our own is 2.5 million light years away. Yeah. So the distances get large, but still, the X-ray telescopes that we have are very sensitive. Maybe that will come along eventually.
Of course, we could just wait until we merge with Andromeda.
Well, yeah, that's absolutely right. Andromeda is going to get a lot nearer to us than it is now. I think it's about 3.5 billion years, Andrew.
Yeah.
So,
we're patient. We can wait that long. But I don't doubt there'll be more on this topic as things unfold. But what an incredible discovery!
Yeah, I think it is. I think it's remarkable. It's something that we probe the middle regions of our galaxy now in ways that 20 years ago we simply would not have dreamed of.
Yeah. So for those of you who are worried that Earth might one day be gobbled up by a big black hole, it's all right. There are only 10,000 of them now. All is good. You're listening to Space Nuts. Andrew Dunkley here with Fred Watson. Now, let's take a little break and find out more about our sponsor, ExpressVPN, rated #1 by TechRadar. This is the one I use. I've been using it for a couple of years and I love it. When I joined ExpressVPN, they were brand new to the market, but I read a lot of reviews and did a lot of comparisons. And there was just something about their business model that I particularly liked. And a couple of years down the track, honestly, can't complain. Their interface is very easy to use. Their service is second to none. I've had to contact them a couple of times about certain things that I wanted to do, and they were brilliant. So you may be wondering why I do need a VPN at all. It's all about privacy. Do you really want big tech companies, governments and others knowing what's going on with your online activity? Even if you're having nothing to hide, it just feels downright creepy. I think you'll agree. And governments are getting more and more interested in what you're doing every day. And so, protecting your privacy is what VPN is all about. And how often do you run across websites that you want to get information from only to find that they're geo-blocked? This is becoming an increasing problem, but ExpressVPN solves that problem for you. Now, if you go to our special URL, you'll see quite a list of things this service can help you with, things you may never have thought of before. As I say, it's the one I use, secure, fast, and it just works. So protect yourself online today and find out more about how to get 3 months free at tryexpressvpn.com/space. That's tryexpressvpn.com/space for 3 months free with a 1-year package. Try expressvpn.com/space to learn more, and you'll find the link details in the show notes and on our website. Now, back to the show.
Roger, you're loud and clear here also.
Space Nuts.
Now, Fred, we're going to talk about something we've talked about many times before, maybe once or twice in this podcast, but certainly in our former lives as on radio. We talked about Virgin Galactic and their plans for space tourism, and all was going well until 2014 when there was a very tragic accident involving their spacecraft, and it's been 4 years now, and they've finally got back in the air with the VSS Unity. So that happened last week, as I imagine.
I believe that's right. I think it was last Thursday. So VSS Unity, that's right, is VSS, of course, Virgin Spaceship, is the replacement for the rocket plane that was tragically lost back in 2014. So that really clearly put a big interruption in Virgin's plans for launching their commercial space tourism venture, which is what Virgin Galactic is all about. It was an accident that happened actually because of human error. The interesting thing about the Virgin spacecraft is that its wings kind of fold up when it's re-entering the atmosphere. It's the process they call feathering, and the back half of this delta wing shape actually folds up almost vertically. It's almost in a right angle to act as a brake to slow the craft down as it re-enters the atmosphere after its suborbital flight. And once it gets down to a reasonable speed, they sort of reconfigure it so it's still, it comes back to a normal shape. But what's happened in the accident is that the feathering mechanism was unlatched when the craft was traveling too fast. In fact, I think it was still going upwards when they released the feathering mechanism, and it basically just it broke up because it couldn't stand the stresses. One of the two pilots was killed in that tragic accident. That possibility apparently has now been eliminated. There is no chance of accidentally unlatching the feathering. So let me just recap the way Virgin Galactic works, because it's not like you climb into a rocket ship and it lifts off and up you go and then come back down again. It is similar to that, but it's a bit more complicated. So there is a what's called a mothership, which is really a very unusual aeroplane. It's a jet, 4-engine jet, but it's got two bodies or fuselages. And the rocket plane, which makes the suborbital flight, sits in between the two fuselages. There's a kind of bridge across between them, which supports the rocket plane itself. So this whole entourage takes off using the jets and flies to a height of something like 15 or 16 kilometers. And then the rocket plane itself, with its 6 fare-paying passengers on board, is released, and a rocket motor on the rocket plane fires and propels the thing upwards. I think it cuts out after about, in normal flight, I think it'll burn for about 30 or 40 seconds before it cuts out. And then the rocket plane coasts up to a height of 100 kilometers.
Wow.
And during that coasting phase, that is when you're weightless. It then starts coming down again, and they do this feathering mechanism to slow it down. And then the whole thing, or the rocket plane itself, lands like a glider in just the same way as the space shuttle did in the space shuttle era. So that's the process. You get something like 3 minutes of weightlessness. You can see from 100 kilometers, clearly see the curvature of the Earth. You can see the thinness of the Earth's atmosphere. I think it's going to be a wonderful experience for those people who have paid their deposit and those who will follow on afterwards. But the problem is this has taken a huge amount of development on the part of Virgin Galactic. And the reason for that is that you don't want an accident. I mean, They have had an accident, but imagine if that had involved, passengers, fare-paying passengers. It would have basically killed the fledgling space tourism industry, probably for decades. So Virgin Galactic is playing it very safe, and that's why it's taken so long. They've been, for about the last, I suppose, probably the last 7 or 8 years, they've been saying, well, within the next year we'll have fare-paying passengers.
They're way behind schedule now.
Always a year away.
And all those people that are standing at the exit gate are probably getting a little impatient.
Waiting for that. Yeah. Well, actually, we've
You've been there.
Exit gate. Yes, it's called Spaceport America. It's at a place called, believe it or not, Truth or Consequences, which is in New Mexico. Why is it called Truth or Consequences? Well, it had another name, this town, and then changed its name to compete in a quiz show on American television.
Oh my goodness.
I know nothing more about that, but Truth or Consequences is the name of the town. And about, I think it's about 20 kilometers from that is Spaceport America. It's in New Mexico. And yeah, there is this monumental runway, 3 kilometers long. It's about 75 meters wide, with a wonderful, basically, the space flight terminal. It's a very elegant building. There is the Spaceport America itself has its own administration building, which we've been in and had a look at. It's all completely empty because there's really nothing going on there. And I think the government of New Mexico invested about, if I remember rightly, it was $212 million US in building this thing. And so they're kind of waiting rather anxiously for the revenue to start flowing from, from launch fees and things of that sort, which Virgin Galactic will pay once they get going. So this is a step forward. What's happened now is that what is sometimes called Spaceship Two, but is actually now called Unity, that has had the first test flight in its final series of trials. And it seems to have been very successful. The mothership took the space plane up to actually about 14 kilometers, released it. They did a 30-second burn, which is actually what I said before was 30 or 40 seconds. I think the final thing will be much longer than that to propel the spacecraft up to 100 kilometers. But with a 30-second burn, they got up to 25 kilometers, and that's a quarter of the way. So it's significant
that's
stuff.
Pretty darn fast, isn't it?
Yeah, it is, yeah. They were traveling at 1.87 times the speed of sound, Mach 1.87.
Still, that's about the speed of the Concorde, isn't it?
Yeah, something like that. That's right. Yeah. But nevertheless, very, very significant, I think, as a step forward. I think they are really very anxious to progress this whole project. I'm sure Richard Branson is. This was a safe and totally, as predicted flight. They landed successfully, and of course what they'll now be looking at is all the data that came back from the telemetry and everything else, just to make sure everything is going well. But I'm sure we'll hear more within the near future, Andrew, of Virgin Galactic.
Yeah, I'm really pleased that they're back on track, because I know there's been a lot of heart and soul poured into this, and Richard Branson never does things by halves. And I think he's just one of these, like Elon Musk, one of these remarkable people who puts his money where his mouth is, and is going to achieve great things, and he will help space development in other ways going forward, not just in terms of tourism, but the things that they're achieving are going to be felt for years and years to come, I imagine. One thing I'm really interested in, and I know I'll never see this because I can't afford the ticket, it's $10 or $15 to get on this thing. When you get on a commercial airliner and they do the safety message, yes. I am busting to see the safety message on Virgin Galactic. I reckon that would be a real hoot.
Yeah, I think it's just hang on and hope for the best.
It probably is. It probably is. And I always kind of laugh when they say, if anything happens, there'll be lights illuminating on the floor for you to follow to get out.
Yes, that's
no one's
right.
ever proved if that works.
That's right.
Anyway,
well,
we watch with
we'll
interest.
see.
Yes,
You
indeed.
never know. You might get your ride. Maybe Richard will tap you on the shoulder someday and say, "Well, you've been spruiking us for all these years, Andrew Dunkley. It's time you had your free flight."
Yeah, I reckon I've given him 10 or 15 bucks worth of publicity.
That's
Absolutely. Australian dollars too, which makes it even less valuable.
Indeed.
We'll hear more on this. We'll keep an eye on Virgin Galactic. You're listening to Space Nuts with Andrew Dunkley and, of course, Fred Watson.
Okay, we checked all 4 systems and keying with a go.
Space Nuts.
All right, finally, Fred, we are going to try and crack open a question from our audience. This one comes from Mark Snelson. Thank you for emailing us, Mark. We're always happy to receive emails and letters and questions from people, especially ones we can answer. He says, I'm a UK listener, only discovered your brilliant, underlined and exclamation marks, no, I'm making that up, brilliant podcast recently, but I'm working my way through the back catalogue. Question for Fred. Is it generally the case that the things we observe from Earth are in our galaxy? Now, he says, I know, as you reported, and in fact was prompted, is what prompted the question, that Hubble has seen a star 2/3 of the way across the universe. Yeah, we talked about that recently. So clearly not everything being studied is in our galaxy, but when things like exoplanets, quasars, etc., are spoken of, roughly what percentage of that stuff is in our galaxy? Ooh, interesting question.
It's a great question, Andrew, and it's worth spending a bit of time on because I think Mark highlights a point that I've always felt is a weakness in the way that we astronomers talk about what we do in a general context. Because what we tend to do is launch into discussions of particular kinds of objects like quasars or like black holes or gravitational lenses or whatever. We talk about these things, but often fail to put them into context. In other words, where do they sit in the grand scheme of things? And Mark's question is exactly that. So, what's in our galaxy and what's out of our galaxy? So the question itself, which Mark postulates at the beginning, is it generally the case that the things we observe from Earth are in our galaxy? The answer is no.
Okay, and we could have stopped there. We could have stopped there and, gone and had a cup of tea.
Mark, I'll tell you, Andrew wanted to stop there. That was.
But wait, there's more.
But wait, there's more. You get a set of steak knives with this as well. So the bottom line is, I guess perhaps the way to address this is in a historical context, because until the 1920s, we didn't know what galaxies were. We knew that there were what were called spiral nebulae, which were strange wispy things that seemed to have spiral shape to them, a bit like a pinwheel, in space. But it was only in 1923 that Edwin Hubble discovered that these are actually big objects a very, very long way away. In other words, they're external galaxies. They called them island universes at the time.
Oh, did they?
Yeah, which is a nice name, an island universe. It's sort of, because until then the universe was basically everything we could see in our own galaxy. And the idea of the galaxy itself came from work done by Herschel back at the turn of the turn of the 19th century. So anyway, going back to the question, we now observe very, very many things beyond our own galaxy. The stuff that we can see with the naked eye, let's take that simplest case. You stand outside under a starry sky, pretty well everything you can see there is in our own galaxy. In other words, it's within the Milky Way spiral galaxy, 400 billion stars, lots of gas, dust, and dark matter. With the naked eye, pretty well all we can see is in our galaxy. The exceptions are, if you're in the southern hemisphere, sadly you're not, Mark, but we are, we see what are called the Magellanic Clouds. There are two nearest neighbor galaxies of any size. They're relatively small galaxies. We call them dwarf galaxies. Their numbers of stars are measured in hundreds of millions or billions rather than hundreds of billions, like our own is. The Large Magellanic Cloud, the Small Magellanic Cloud, the large one is about 175,000 light years away. I think the small one's about 200,000 light years away. They're called large and small, partly because that's the way they look in the sky. The small one is further away, so it looks smaller, but it also is smaller as well. It's not as big a galaxy as the large one. And the other thing that you can see actually in the northern hemisphere with the naked eye is the Andromeda Galaxy itself, the one we were just talking about a few minutes ago.
The one we're going to smash into.
The one we're going to smash into in 3.5 billion years. That is a fuzzy patch. You need a dark sky to see it. It's a lot easier if you start with binoculars, because you can pick out this fuzzy patch fairly easily with binoculars and then strain your eyes. It's fairly low on our northern horizon, seen from here in Australia, but up in the northern hemisphere it passes almost overhead. That's the Andromeda Galaxy, 2.5 million light years away. Really, it's the furthest thing that you can see with the unaided eye. A few people can see another one called M33, but that's fainter and is much harder to find. And I've never seen it with the naked eye, although I have seen
I think you've got to be under 5 years old.
Yeah, they're probably right. Yeah, you've got absolutely perfect vision. So those are the only things we can see that are outside our galaxy with the naked eye. But as soon as you've got telescopes, and even small, amateur telescopes, or actually even binoculars, that opens up what we call the extragalactic universe, the universe beyond our galaxy. So just to go into the details that Mark mentions, exoplanets. Yes, it's true that pretty well all the exoplanets that we've discovered, these are planets orbiting other stars, are within our own galaxy, because you need fairly sensitive measurements to detect exoplanets. Usually it's by the way the light of the star dips as the planet passes in front of it. And the planet's a tiny fraction of the size of the star, so the dipping of the light is not much, but it's still detectable. So we have, as I recall, detected maybe 1 or 2 exoplanets in other galaxies, other nearby galaxies, but most of them, the 3,000 or so that we know, by far the vast majority of those are within our own galaxy. So they are definitely within the Milky Way galaxy. Quasars are not. Quasars are actually, they're delinquent galaxies of themselves. They're a phase that galaxies seem to go through relatively early in their lives, in which the supermassive black hole at the middle starts emitting copious amounts of energy because it's basically gobbling up a lot of material. We think in today's universe quasars are extinct, but because in the universe we're always looking, as we look out into space, we're always looking back in time, we can see them as they were millions and sometimes billions of years ago. So quasars, very bright objects.
That's the thing that really blows my mind. We are seeing things that no longer exist.
That's right. Well, that's right. Yeah,
it's crazy town.
It's just one of the weirdnesses associated with the universe.
Yeah.
What's happened to these quasars? They exist in the sense that their host galaxies are still there, but their host galaxies have now settled down into comfortable middle age, rather than this delinquent energetic phase that they seem to go through early in their lives. It's almost certain that our galaxy went through a quasar phase, a few billion years ago. Good thing we weren't around, because the amount of energy that you get from them is extremely devastating. It's a very large amount of energy. So quasars are definitely extragalactic. Most supernovae that we see, well, actually all of them, supernovae are exploding stars. The last one in our own galaxy was, I think, the supernova of 1576.
Fred took a photo of it.
Correct, yeah. Which is Tycho Brahe's supernova. There was one in 1604, that probably was in our galaxy as well. That's Kepler's supernova. The most recent supernova visible with the naked eye was actually in the Large Magellanic Cloud, the supernova 1987A, which is, as I said, one of our nearest neighbours in extragalactic space. But by far the majority of the supernovae that are discovered are seen in other galaxies. And in fact, this is one of the key ways of calibrating the dimensions of the universe, because these supernovae tend to act as standard candles, at least certain types of them do. So if you see one flare off, and it might be bright for just a few days or weeks, but you see one in a distant galaxy, you know what its intrinsic brightness is, and therefore you can tell how far away the galaxy is. That's one of the main ways we use to work out, for example, that the universe is expanding faster now than it ever has, than it was when it was half its present age. So the catalogue of different objects within the universe, these distant neutron stars that collide and cause gravitational waves, they're in extragalactic space. I guess the majority of the interest of cosmologists, scientists who are looking at the early history of the universe, the majority of them are now studying very, very distant galaxies. In other words, galaxies that we see in a very youthful stage in their existence. So the extragalactic universe, the universe beyond our own galaxy, is very, very well studied indeed, Mark. And it's only things like exoplanets, the solar systems of other stars, the gas clouds in our own galaxy, the supernova the black hole at the middle of our galaxy. Those are the kinds of things that are within our own galaxy, and within distances measured in thousands of light years rather than billions of light years.
Okay, so as I always attempt to do after Fred's spent 10 minutes explaining the answer to someone's question, as far as the naked eye is concerned, probably 99.9% of what we see is in our own galaxy. When you bring in the technology, it changes the game completely. I won't even attempt a percentage, but it would be significant. As far as exoplanets concerned, it's many thousands that we've found and only one or two that are not in our galaxy. But when you're talking quasars, well, they don't exist anymore, so none. But we can still see them because of light and distance.
Yep.
Does that size it all up?
It does. That's a perfect wrap-up. And in fact, why didn't you start with that? And then I wouldn't have had to go through all the other stuff.
I made the offer. I didn't make the offer.
No, your offer was no.
Yeah, pretty well.
It's not enough.
Yeah, so, I mean, do you want to hazard a guess at everything we can see with all the technology available versus what you can see with the naked eye, which is almost only our own galaxy? What's the percentage?
It's a great question, actually. I mean, I suppose...
It's too hard.
It is and it isn't, because the sky itself, we haven't really touched on this, but when we astronomers look at the sky, if you want to look at the sky beyond our own galaxy, you look away from the Milky Way itself. And the Milky Way is that band of light that runs all the way around the sky. And it sort of marks the disk of our own galaxy. We sit in this disk. So because you're in a disk of stars, when you look around, you're going to see this strip of stars all around the sky. So if we want to study our own galaxy, that's where we look at the millions of stars in the Milky Way. If we want to study the extragalactic universe, we look away from the Milky Way. We look at what are called the galactic poles. It's the region where you're looking more or less at right angles to the plane of the Milky Way. And so the number of objects that we study, I bet they're about equally distributed between the two. The extragalactic stuff and the galactic stuff. So roughly 50-50.
I was going to say that.
Yeah, of course.
It's a good, solid, arguable guess.
Yeah, it's more or less what I'm doing as well, Andrew, but you get the idea.
Yeah. Okay, Mark, I hope we answered your question, and thanks for sending it in. We appreciate it. And keep them coming. We've got a few more to try and sort out, but we'll hopefully get to them in the not-too-distant future, depending on light and distance. Fred, thank you as always.
Great pleasure, Andrew. Good to talk, and we'll speak again very soon.
We will indeed. Fred Watson from the Australian Astronomical Observatory. And don't forget to tell your friends about us, especially your geeky friends. They seem to like us most. And we will talk to you again next week on another edition of Space Nuts.
Space Nuts. You've been listening to the Space Nuts podcast.
Mission complete, Houston.
Subscribe to the full podcast on iTunes, Audio Boom, and Stitcher, or your favourite podcast distributor. This has been another quality podcast production from Bytes.com.